Today we're going to solve rational equations. When solving rational equations, we need to check for extraneous values. Extraneous values would be values that we get for a solution that make one of our original denominators equal to 0. Remember, the denominator can never equal 0. There are a couple ways to work with rational equations. You could combine these two rational expressions on the left side, and then you would have a fraction equals fraction, which is a proportion. That's really easy to solve by cross multiplication. But if you don't want to deal with so many fractions, this is your chance to get rid of the fractions. We couldn't get rid of the fractions in 7.2 unless we were truly reducing everything out. We couldn't get rid of the fact that there were fractions in 7.3 because those were all expressions. You're only allowed to multiply an expression by a special form of the number 1. But guess what? For an equation, you can multiply an equation by anything as long as you do it to both sides. That's what keeps it equivalent, and that's why you have so much more freedom when solving an equation than you do when simplifying an expression. So I can multiply both sides of this equation by the least common multiple, and then none of my fractions would be fractions any longer, and I could solve an equation with no fractions. Let's begin by finding the LCM. It's got to be at least as big as the biggest denominator, which is k squared. Now, does k go into k squared? Yes, it does. Let's multiply the left side of the equation by k squared and the right side of the equation by k squared. For the left side, you'll need to distribute the k squared into each of the fractional terms. This is going to give you 5k squared over k plus k squared over k squared equals 2k squared over k squared. Remember, when you're multiplying both sides of the equation, you're only multiplying the numerator because you're multiplying by k squared over 1. Let's reduce this equation. 5k squared divided by k is 5k. K squared divided by k squared is 1. 2k squared divided by k squared is 2. Wow, that equation looks so much simpler to solve. Continue solving. And k equals 1/5. Would 1/5 make this denominator equal to 0? No, it wouldn't. So 1/5 is not an extraneous value. But let's check to make sure it still makes the equation true. Remember, this is an equation, so we can check by plugging it in. So we can check by plugging in our solution. So 1/5 is our answer. You also don't need to include excluded values for a rational equation because you're literally looking for only the values that make it true. And we just have to make sure our solution is not an excluded value of any of the denominators. For number 2, the left side already has common denominators. So I'm going to combine those two fractions before multiplying everything by the LCM. Now it's quite clear to see my LCM is 3r squared because 3 goes into 3r squared. So multiply both sides of the equation by 3r squared, or 3r squared over 1. You do not need to multiply by a special form of the number 1 because this is an equation. We have more freedom with an equation. We can do anything to an equation as long as you do it to the left and the right side. And if you're comfortable with reducing in the same step that you're multiplying that LCM, that's fine with me. I'm just going to show you what it looks like so that we don't do too many steps at once and forget any parts. Continue solving. So our answer is -1/2. -1/2 would not make either of these denominators equal to 0 because only 0 would. So we know -1/2 is not extraneous, but is it the solution? Let's plug it in to check. And now I know negative 1/2 is definitely our answer. Try number 3 and then press play when you're ready to check. Negative 6/5 would not make any of our denominators 0, so it's not extraneous, but let's plug it in just to make sure we did all the math right. So negative 6/5 is indeed your answer. For number 4, let's factor our denominator x squared minus 9 to find our LCM. Each of the other denominators goes into x plus 3 times x minus 3. Now I'm going to multiply both sides of the equation by the LCM. Now we can reduce so that we no longer have fractions in our equation. Distribute, and it looks like we have a quadratic, so we'll want to bring everything to one side to make this equal to 0 and see if we can factor. Now, when you go to check each of these solutions, negative 3 actually makes our denominator equal to 0, so it cannot be a solution. Negative 3 is an example of an extraneous solution, one that appears to be a solution but is not. So is 3/2 our only solution? Let's plug it in to check. Indeed, our only answer for number 4 is x equals 3/2.